5, what we're talking about is just what to expect from the review. And I'm going to have each worksheet numbered. Like, hey, this is what we did last week. Worksheet number 1. We looked at a rational equation that was in this form, y equals a over x minus h plus k. And we looked for the 4 key features of this problem. So the first example, let's see, to find the y-intercept, you plug in 0 for x. To find the x-intercept, you plug in 0 for y. Those are 2 of the key features I want you to be able to find on your graph for these rational functions. The other 2 I want you to find, the vertical asymptote and the horizontal asymptote. The vertical asymptote is always the h value and always has to be written as an equation. So vertical and horizontal asymptotes must be written as an equation. Vertical asymptote is always going to be x equals. Horizontal asymptote is always going to be y equals. The x and y intercepts must be written as ordered pairs. If you don't write these on the quiz as ordered pairs, you're going to get it marked wrong. If you don't write the vertical and horizontal asymptotes as equations, you're going to get marked wrong. If I say, hey, what's the vertical asymptote? And you say it's 3. Nope, sorry, it's x equals 3. You have to say it as an equation. Okay? And it says the vertical asymptote is the h value. So you might remember from here, you say x minus h equals 0. Add h to both sides, x equals h. That's the vertical asymptote. X equals h. The horizontal asymptote is the k value. Literally whatever the k is at the end of the equation is what your horizontal asymptote is. Okay, that's the idea here. So on the quiz tomorrow, I'm going to give you a problem like this. You should expect a problem in this form. And I want you to find those 4 key features. So find the y-intercept, find the x-intercept, find the vertical asymptote, find the horizontal asymptote. Right now there are 2 practice problems, A and B. I want you to try to get both of those problems done, and we'll look at one of them in just a minute here. All right, I'll write down the answers for both of them, but we're going to look at one of them in just a minute here. So take a minute and look at these 2 problems. So problem A, to find the y-intercept, plug in 0 for x. So y-intercept we'll do in red. Y equals 2 over 0 plus 4 minus 3. So y equals 2/4 minus 3. 1/2 minus 3. 3 can be rewritten as a fraction, 6/2. So y equals -5/2. In order to get credit, what I did was I plugged in 0 for x. So I need to write that as an ordered pair. And I got 5/2 for y. And I showed my work algebraically. All right. I want you to be able to write these as fractions, but then it might help you for when you're graphing to also write this as a decimal, like, oh, that's -2.5. Okay, so just to put that in your calculator and say, I got a -2.5 there, so I know where that value falls as well. To find the x-intercept, plug in 0 for y. 0 equals 2 over x plus 4 minus 3. Start by adding 3 to both sides. Next, I'm going to multiply both sides by x plus 4. And I'm going to get 3x plus 12 equals 2. And now I just have to solve algebraically for x. It's kind of tricky there, but you have to get rid of that denominator of the fraction completely. That's the hardest part for students, I think. Get rid of that denominator. I divide both sides by 3. I get x equals negative 10 thirds, which is negative 3.33. So the negative 3.33 is going to help me graph it, but the negative 10 thirds should be my algebraic result. Show all of your steps. It's not a lot of work. We're going to have not a lot of problems on the quiz, so we should be able to have plenty of time to show our steps here. All right. I'm going to go ahead and take my graph, and I'm going to sketch a y-axis and an x-axis here. Now my vertical asymptote, I need to, find out what the h value is. So set the denominator equal to 0 and solve for x. So it's negative 4. X equals negative 4. Last one, the horizontal asymptote. Just whatever the y value is, it's at negative 3. Y equals negative 3. That's the horizontal asymptote. That's how we show our work algebraically. When I'm graphing this thing, I'll put a little scale on here and say, hey, this goes by a scale of 1. We're counting ones in each direction. Then I have x equals negative 4. So I'll put a dashed line to represent that. And then I have y equals negative 3. So I'll put a dashed line to represent that. And then I take my x-intercept and my y-intercept. Negative 5 halves, or negative 2.5. It's going to be the y-intercept. And my x-intercept was negative 3.3. Or 3 1/3. And then I can go and sketch my line through there. And with any of my graphs, you have to remember rational functions are always going to have 2 lines. They're going to be like kitty corner of the asymptotes from each other. So that means if there's one up here, there's going to be another one down here somewhere. And I have to sketch that as well to get full credit. So to get full credit on one of these problems, show your work. The x and y intercepts might take the most time in terms of work. Get those fraction answers and box those up. And then show how you're finding those vertical and horizontal asymptotes. Sketch them all on the graph. Your 2 intercepts gives you an idea of where the lines are going to go for the asymptotes. That's what this looks like. That's what one problem with work should look like. All right. Takes me about 5 minutes to do one problem. All right. It might take you a little bit longer, maybe 10 minutes to do a problem, but the quiz is going to be, I think, pretty short for most of us. Maybe a half hour, 45 minutes for most of us to complete. Just something to expect tomorrow. All right. For part B, I'm just going to write down what the intercepts are real quickly and everything. So the y-intercept, we should have 0, 6.3, but we need to be able to show algebraically that that's 19 thirds. The x-intercept, we should have 3.8, 0, but we need to show algebraically what 3.8 is. All right. So 3.8, what does that come out to? 38 tenths, 19 fifths, okay? 0. So you need to show algebraically that you know how to find that value for the x-intercept. Vertical asymptote for problem B, x equals 3, the horizontal asymptote, y equals 5. All right, that's what you should expect for these types of problems. All right, identify your vertical and horizontal asymptotes, identify your x and y intercepts, It's okay to leave your answer in a decimal because that'll help you graph it, but you have to be able to show me algebraically where the fractions came from. Okay. From worksheet 2 last week, worksheet 2, we specifically talked about this other form of the equations, y equals ax plus b over cx plus d. And for these forms where you don't have a plus k at the end, everything ends up staying the exact same except for the horizontal asymptote. But we still plug in 0 to find the y-intercept. Plug in 0 for x to find the y-intercept. We still plug in 0 for y to find the x-intercept. And to find the vertical asymptote, set the denominator equal to 0, which is essentially what we did before on the previous version. The only one that's different is the horizontal asymptote. To find the horizontal asymptote, use the leading coefficients as a ratio. So the leading coefficients as a ratio. And that's where we had to look at the degree of the numerator over the degree of the denominator. So in this example, the degree of the numerator is 1. The degree of the denominator is also 1. So it might be useful to reference worksheet 2. Remember, it's open notes on the quiz. So if you have good notes for worksheet 2, I would recommend referencing that while you're on the quiz. Hey, they're both degree 1. So now we look at the leading coefficients. Leading coefficients happen to be 1 and 1. So in this case, the horizontal asymptote is y equals 1 divided by 1, or just 1. Then we have to find the vertical asymptote, the x-intercept, and the y-intercept. The same 4 values. All right, except this time we're dealing with this x minus 6 over x plus 3. All right. Both forms, or both versions of this equation, or both forms will be on the quiz tomorrow. So you need to know how to do both the forms from worksheet 1 and worksheet 2. Be ready for that. All right. Why don't you guys take a minute and work on these 2 problems, and then I'll write down the answers for you. All right, and if we want to see one worked out, we can do that. But take a minute and work on these 2 problems. Okay, so after going through those two problems there, the last couple things we talked about, worksheets 3 and 4, were simplifying rational expressions. Worksheet 3, simplifying rational expressions. We said we're going to start each problem by factoring the numerator and denominator. That's the first step. Next step is we're going to divide out like terms. So once we're in factored form on our numerators and denominators, we look for any like terms and we can divide those out. And then the last step, I finish up by condensing the numerator and denominator as needed. All right, maybe you don't need to do any condensing, maybe you do need to do some. But that's the last step. Make sure you condense as needed. So I got two practice problems here. You want to simplify those problems. Before we do that though, why don't I just go ahead and finish up the rest of this. We'll talk about worksheet number 4 real quick here. Worksheet number 4, multiplying rational expressions. When we multiply, we do the same thing where we factor the numerator and denominator first. And then we follow the same process where once it's factored, we can just combine it all together. We're just going to write it as one line divided by another line. And then we divide out like terms. The last one from worksheet 4 as well, dividing rational expressions, you're going to need to multiply by the reciprocal. So you're going to multiply the numerator by the reciprocal. Not the numerator. Multiply the first expression by the reciprocal of the second. Okay, that's what we would do for the last part. So there's 6 practice problems here. Why don't you guys work on those 6, and I'll put down the answers here in a second. And if you have any questions on any of these 6 problems, please write into the chat or unmute yourselves and ask those questions. But I'll put those answers down in just a minute here. All right, so I have those 6 problems. I've got the answers written down here for you guys. So, so you can check your answers. If you think something is not quite right, let me know. But remember, at the very end, the last part is condensing the numerator and denominator as needed. So part B of the very last example, the dividing one, that's a lot of condensing at the end that needs to happen in order to get back to this form that I have. Okay, so that covers everything for today. If you have questions on any of these 6, I'm more than happy to show you the work that goes with it. Otherwise, have a great day and good luck on the quiz tomorrow. I'll see you guys tomorrow morning or see you tomorrow at noon. Thanks so much.